Hello, grade 11s and grade 12s. We are still on circle geometry. This is part 2 of our circle geometry question. The last one just ended with me introducing theorem 4, which says an angle subtended by a chord of the circle on the same side of the chord are equal, which means this side and this side are equal. D and C are equal, and A and B are equal. So when you start here, you go, this line will take you here, and this long one will take you to C, and you just come down, you will get to a B to show that they're equal. So when you come from B, you will go like this and then go down this way. They will meet here. So this one and this angle are equal. Also, when you start at C, you will go this way and then they will meet there at D. Or when you from D, you will go down like this and then you will meet at C. So this is what we call the bow tie. This is to prove the bow tie. So you say if this is 30 degrees, then C will also be 30 degrees, and then we'll say angles in the same segment. That will be the reason why. Or if this is 20 and this one also will be 20, and these are angles in the same segment, so that will be your reason. And you have to draw a line like this. You'll be given an extra sheet when you are given this bow tie as well, and you have to draw a line here. This gives you two triangles which meet here at B, right? Those are the two triangles which meet at B. So it means really that this, we can also prove angle in the same segment with it. That is how you do it, guys. So you just say 30 equals to C, and those are angles in the same segment. Or you can say this 20 is equals to this angle B. That is also angles in the same. We say here, we say that angles in the same segment, line subtended equals to angles, or you can just write it like this in short, but you can just say angles in the same segment. All right, now here we have theorem 5, and what theorem 5 says is that the opposite angles of a cyclic quadrilateral are supplementary, which means they add up to 108. So we'll say opposites of a cyclic quadrilateral when you write it as a reason. So this is a quadrilateral. How do you know? It has 4 sides. So anything that has 4 sides, it's a quadrilateral, right? So it says opposite sides are equals to 180. So everything, it has to be 360. Let's say here we have 110, and here we have 85 degrees. So here, for this to get C, you're just gonna say 180 A plus C equals to 180 degrees. Why is it that we say opposite angles of a cyclic quad like that, right? So A is 110 plus C equals to 180 degrees, and this is, so the C equals to 180 degrees minus 110, and then C is equal, then C equals to 70 degrees. So you will just do the same for this one and this one. Now let's go to theorem number 6, right? So theorem number 6 is a cyclic quadrilateral. It's a quadrilateral that has an extension there. So what we say is that an exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So exterior angle of a cyclic quadrilateral. What that means is that A equals to this, right? This is the exterior angle. It's equal to the interior opposite. So they are opposite. If this extension was done here, then this angle here, not this one inside, this one exterior angle is equals to the inside, the opposite one, which is inside. So this is one of the things that you have to know, that when you have anything, a complicated drawing, but we have an extension like that of this quadrilateral, then it's equals to the opposite interior one. All right, let's say you have this, it's 80, this one is 100, let's say this one is 110, and then this one is 70 degrees. You are looking for this, right? So maybe this is C1 and this is C2. So we will say C2 equals to 80 degrees because we have this one. Because what? It's exterior angle of a cyclic quadrilateral, right? Or if you have this one, you can find this one. And another thing, these two angles should add up to 180. So if you have 100 here, you can find this one. And then when you found this one, you can have this one. Or even if you have this one, you can still find this one, because opposite angle of a cyclic quadrilateral should be equals to 180, right? So let's move on. I hope you understood theorem 6 is as easy as that. If the extension was here, this was going to be equals to this. If the extension was here, this one was going to be equals to this. So you just look at the opposite angle. All right, this is theorem 7. So with theorem 7, we have a circle, a beautiful circle here. This is the center, this is the radius, and this is the tangent, touches the circle once. So this is what this theorem says. A tangent to a circle is perpendicular to the radius at the point of contact. This is tan radius. When you are proving that, you prove tan radius. So this was going to form a 90-degree angle there. So when a radius and a tangent meet, they form a perpendicular, right? So it's that they form a 90 degrees. Yeah, so here we can say maybe prove that AC is a tangent, right? Maybe let's say, hypothetically speaking, maybe that's a question in your exam. Then you will say if line A, B, C, A, B, C is perpendicular to radius OB, right? They are perpendicular. You see that? That is why the reason is 10 radius. That's the reason. So what you say, it's therefore then OB, which is this one, is perpendicular to A, B, C. So you have proven that AC is a tangent, and then therefore AC is a tangent. That is as easy as that. You see, there's no chord here. This is not theorem number 1. This is theorem number 7. It's not a radius and a chord. It's a radius and a tangent. So a radius and a chord forms 90 degrees, and a radius and a tangent also forms 90 degrees. They are perpendicular. That's what Euclidean discovered. This is theorem number 8. So we have this beautiful circle and these two tangents. So theorem number 8 says that two tangents drawn to a circle from the same point outside the circle are equal in length. That's tangent from same point. This is what you say. So which means CA is equals to BA. And if maybe here you have 60, this angle is 60, this one is also 60, and that is opposite sides of a triangle. They form a triangle, right? So this side is the same as this side. That is tan radius. So not tan radius, that is 10 from same point. So CA is the same as BA. So angle B is the same as angle C. That's what you have to know. That is 10 from the same points. That is theorem 8. As easy as that. Let's go to theorem 9. Here we have theorem 9. Here is the circle. And theorem 9 states that the angle between a tangent to a circle and a chord drawn from the point of contact is equal to the angle in the alternate segment. So this is a tangent and this is a chord from this point going to that point. This is also a chord from this point to that point. This is also a chord because it's not drawn from center. This is also a chord here. So this says angle between a tangent and a chord to a circle drawn from point of contact is equal to the angle in the alternate segment. So what you have to know is that this angle here is equals to this angle. You see it's facing this, so it's equal to this angle. This angle between the tangent and the chord is equals to this angle, and this angle here between the tangent and the chord is equals to this one. Now when you get this type of question, another thing you have to do is that you have to know that you have to draw. This line must pass at the center. You have to make this drawing. You can go this side or that side, and then you can label this, maybe say F. We will label this our drawing as F, and then here we're gonna have B1, B2, and then here we'll have E1, and also you will have E2, right? This is what we have. So now we can prove that C, B, CB and D, yes, this triangle here, CB and D,